So in the demo, I'm going to discuss mainly what is big data, what is Hadoop, okay, and what is prerequisites to learn Hadoop, okay, and why big data is so popular in nowadays, and what is the roadmap of big data, okay, and how is the job opportunities and job market about big data. So why again? Like most of the projects are migrating towards big data, okay, and we're going to see what is data analytics, okay, how the big data and data analytics playing important role in today's market. Okay, so we're going to see a few things here. Okay, so let me start the demo. So before going to presentation, just let me start the demo with some simple real-time scenario. So for example, assume there is a customer. Assume there is some customer, okay, bank customer. So assume this customer visited this bank, okay. So let's take some bank, ICICI Bank. Okay, so a customer visited ICICI Bank, okay, and he requested for some bank statement. Maybe he requested for some 1 year bank statement, okay. So what will happen? The representative will log into the account, right, and he will take the printout and he will give it. Maybe the service, so maybe he will give the statement. So the service request will be closed maximum in 5 minutes, right? Okay, so now assume the second scenario. The same customer went to ICICI Bank, okay, but now he requested for some 10 years bank statement. Some 10 years, 15 years, 20 years bank statement, something for some financial purpose. He requested for some 10 years bank statement. But this time, the representative, he will say, sir, you are requesting for historical transactional data. 10 years of the statement is something historical transactional data, which I cannot provide you immediately. I have to raise a request to backend system. Okay, I have to raise a request to backend system, and they will process the request, and you will receive the statement maybe in next 24 hours, and they will charge some amount for that. Okay, so why the difference? When a customer requested for a statement here, 1 year statement, when this guy could able to provide it immediately, when the same customer requested for 10 year statement or some 15 years or 20 years, whatever it is, why can't you provide immediately? Okay, why he is raising request to backend system, and why the time taking process? So the reason is, so basically the data, like 1 year, 2 year, the recent data, it will always sit in our RDBMS systems, right? So the recent data, whatever we are going to maintain in organizations, it will sit always in our OLTP databases, that is RDBMS systems, like Oracle. It could be anything. It could be Oracle, or MySQL, or Sybase, or DB2, or Postgres. Okay, it could be any database. But in the second scenario, if you see when the customer requested for some historical transaction statement, okay, so he cannot provide immediately. Why? Because this historical data, like 20 years, 20 years, 30 years, 50 years, 100 years, okay, whatever the volume of data, period of data it is available, it will sit in backend systems, what we say, data warehouse systems, right? Like Teradata, or maybe Neteja. Okay, it could be any warehouse system. Okay, so this guy has to raise a request to some backend system, these warehouse systems. So the warehouse systems normally they will have batch. They'll have the batch jobs. Batch jobs mean scheduled jobs. Okay, so once the request comes, they cannot process immediately. Okay, the request will keep it in some queue, and once the job is scheduled, the jobs will run periodically. Okay, that's what we say. Batch job is nothing but it's a scheduled job. So they don't run all the time. They will run periodically based on the scheduling time, like once a day, once an hour, or maybe twice a day, like that. So most of the data warehouse system applications were what we say ETL applications. ETL applications, they are scheduled jobs. So once this request comes, they will keep the request in a queue and the application is started. So it will take the request, it has going to process the request, and it will send the statement back to customer. So obviously it will take at least some couple of hours. But if you go to big data systems, okay, if I go to big data systems, in both the scenarios, even if I request a 1 year data, if I request 10 year data, 50 years, 100 years of data, big data systems can provide you the data within the less time than what RDBMS systems are taking. Even it can do less than the 5 minutes of time, irrespective of volume of data you are requesting. Okay, so it can process and send you the volumes and volumes of data in less times using a mechanism called parallel processing mechanism. This is a very important and the core feature in big data that is playing important role in big data success. Okay, so this parallel processing mechanism is something what has been designed in the big data architecture. So it does the things. So, okay, so suppose here, if you go for any OLTP databases, I mean Oracle, MySQL, any databases, right? They are all designed on sequential processing mechanism. Suppose if I run a query, okay, so the query, how it's going to load the data and run the query on the table. It's going to read the records one by one, and it's going to perform that query, and it's going to return the result. That is what we say sequential processing. But if you go to big data systems, even the warehouse systems, most of the systems before they have followed sequential, but now, in the new versions, these guys also following this parallel processing mechanism. Big data, this is again, guys, when I say parallel processing mechanism, this is not something newly invented in big data. This parallel processing mechanism, actually, this architecture is implemented by Google in 2000s. It's implemented around 2002, 2003. Later, many companies adopted this, that core principle in their products, in their tools, in their technologies, in their applications, what they build. Even IBM, Microsoft, Oracle, many guys adopted this architecture. So similar way, Big Data also adopted this parallel processing mechanism. Big Data also adopted this parallel processing mechanism, but it did it in more optimal way. It's been implemented in more optimal way in Big Data. So there is a reason it's playing important role and key role in big data success. Okay, so we'll discuss more about this characteristic in detail in the course. And similarly, if you see the scalability. So the reason why, first of all, the data warehouse systems came into market and the RDBMS systems there, okay, in traditional, in olden days, okay, why the data warehouse systems has been introduced? Because of the limitations in the RDBMS systems. Limitations, what are the limitations here? So these systems, they have storage limitations, right? If you take Oracle, MySQL, any database server, they have certain limitation how much they can handle the data. For example, if I take Oracle server, Oracle high-end database server can store maximum 16 terabyte of the data. 16 TB is maximum what it can handle. But if you see 16 TB is maybe it's not a small storage, it's a high storage only. But 16 TB is not only the data, right? Because if you see the companies are handling even terabytes and petabytes of data. So that is the reason to handle higher limitations of the data warehouse systems came into market. But they have again certain drawback in terms of scalability. So to make it more clear, So basically the data warehouse systems, right? They will run on clusters. So you guys may know what is a cluster, right? Cluster is nothing but it's a network where you will have n number of computers or nodes, whatever you say, connected to each other. So a cluster is nothing but it's a group of nodes connected to each other in a network. Okay, so this is cluster. Okay, so this is a 5-node cluster. Okay, it's a collection of nodes connected to each other in a network, and they can exchange data and they can communicate to each other. Any node can talk with any node. They're all in LAN basically. Okay, so when I say node is nothing but it's like our CPU cabinet. Okay, so a node will have its own hardware, its own hard disk, own RAM, own buffer, own motherboard, everything. So this is like collection of computers, what we say. Okay, but we say it's a collection of nodes. Node is like also one individual cabinet. So basically clusters by default runs with an architecture, what we say master slave. It means they run as master slave. That means there will be one master system and remaining systems play slaves role. I mean, this is the default architecture. We have different architectures again. We have multi-master architecture. Okay, we have multi-master architecture. I mean, that we are going to discuss later in the Hadoop course. So assume this is a master system and these are all the slaves. Okay, like this is slave 1, this is slave 2, this is slave 3, this is slave 4. Okay, so this is a 5-node cluster, 1 master, 4 slaves. So you assume this is a Teradata cluster. Okay, why I'm telling all this is because the Hadoop also follows the same cluster model. Hadoop also runs on the clusters. Okay, looks like so almost in similar way. Physically, they look like in similar model. So assume this is a Teradata cluster, some data warehouse cluster. So this is 5-node cluster. Assume this is a 2 TB. It has a 2 TB hard disk. It has 1 TB, 1 TB, 1 TB, 1 TB. So 4 plus 2, 6 TB capacity cluster. So 6 TB again is not big, right? One day my 6 TB is full. So what they will do? They have to add nodes. The ETL admin, he has to keep on adding nodes to the cluster. He has to keep on adding new nodes. So based on the demand, he will keep on adding. He is going to keep on adding the nodes to the cluster like this. But the problem here is when they want to add nodes to the clusters, they have to restart that complete system. Basically, they have to restart some services in the master. So basically, there will be certain maintenance activities they have to do, so the cluster will not be available. A complete cluster will not be available. So the challenge here is, as I said, the ETL, the Teradata systems or Netezza systems, these ETL systems, they run mostly batch jobs. So batch jobs, right, yes, batch applications means, as I said, it's a scheduled jobs and they are automated jobs. Just they will trigger automatically by themselves and they will run for hours and even days. If you go for insurance, banking applications, right, the batch applications will run for days, even hours, long hours. So when some applications are running through scheduling, okay, if something, any cluster upgradation is done, so restarting these things, right, it will impact the jobs what is running. So what they have to do, either they have to stop the jobs and then do the maintenance activities, but if jobs are stopped, it's going to impact the application. Why? Because is batch applications are very, very important. Okay, these reports, whatever the outputs generated from batch applications, what we say batch reports. The batch reports are very, very important for day-to-day business activities. Depends on the batch reports. Most of the business activities will be planned in the coming the organizations. I mean, today, based on today batch reports, tomorrow business plans will be there. So most of the decisions will be depends on this batch reports. So this batch reports plays important role. Batch jobs plays important role. And they will run periodically, maybe daily, hourly, or whatever depends on the application. So when some applications are running, if they want to, if the cluster is upgraded, if they want to do maintenance, that is very tough, maintenance activities. So basically what they do, ETL admin, they have to check off time, so where that no job is running, they have to do it, but that is very tough. That is the issue actually they are facing. So what they have to do, they have to intimate the team saying that, boss, don't schedule any jobs on so-and-so time and so-and-so date. Okay, so we are planning some maintenance activities for half an hour or 1 hour. Okay, so they will stop and they will, but that is not, again, good process, right? But if you go to Hadoop, so assume now this is a Hadoop cluster. Same situation, 6 node Hadoop cluster, so it is full. Hadoop admin added new nodes. Some Hadoop applications are running. So Hadoop also, they have to restart something, right? But Hadoop architecture again has a dynamic intelligence. So when the cluster is upgraded, that means when new nodes are added or some nodes are removed, without a single click or single command, basically without admin involvement, admin login itself, the Hadoop master has the intelligence. Dynamically, it will detect the nodes that is been added to the network and been removed from the network, and it will start replacing them. So basically, you don't need to do any maintenance activities, even restarts. So Hadoop has that intelligence. Dynamically, it will decide, it will identify the nodes that is been added to the network, and it will start replacing them. That's why we say Hadoop clusters are more linear scalable. Also, we say it's a horizontal scalable systems. And next, guys, similarly here, like hardware failures. So we know if a database is down, how it's going to impact our regular OLTP applications. I mean, the web applications or mobile or enterprise applications who are dependent on that OLTP database. So that it's going to impact. Right? I mean, recently happened in many companies like Flipkart, Jet Airways. Of course, if the database server is down, nowadays they are maintaining the backup server. If main server fails, the backup server will be there. Okay, so active passive servers. If active server is down, passive server will become active. But in the worst case, both servers are down at the same time. So there will be no option. So your application should be down, will be down. So we know if an OLTP application is down, how much impact it will be there on the customer revenue as well as frame wise. So if you come to warehouse system again, so here let's take this diagram again. So assume I have some ETL application running, some warehouse application, some Teradata application is running. So it's running for last 4 hours. So almost some 80% of the processing is completed. Okay, so this application at 80% when it's running, unfortunately in the cluster, some node is dead. I mean, some node is dead. That means it's failed because of some reason. Maybe hardware issue or power issue, whatever, the node is dead. So this application, whatever is running for last 4 hours, okay, now to finish remaining 20%, it needs some data from here. So what it will do? Since the node is gone, no more accessible, it will try, and the application will fail. So whatever it spent the last 4 hours is going to waste. The resource, whatever is consumed, it's waste. Again, ETL admin has to fix this node. Again, they have to start. Again, it will take some 4 to 5 hours. But if you come to, again, Hadoop, guys, so assume the same scenario. So now assume this is a Hadoop application. Okay, so assume now I have some Hadoop application running, maybe from last 1 hour, so same like it's completed 80%. Okay. So at this scenario, again same situation, like one of the node in the cluster is dead. One of the node in the cluster is dead. One or two nodes maybe. Of course, there is a limit again, so the nodes are down, but this application to finish remaining 20%, it has a dependency on these nodes. It needs some data from here. So what normally happens if the node study is not accessible where the dependency is there, the application will try for some time and it will fail. But in Hadoop, in this scenario again, the applications which are running, if they have dependency on the failed nodes, so still the Hadoop master again plays important role. It will make sure that application, even if it has a dependency on the failed nodes, it will make sure this application will get successfully executed and get the results generated without any impact. Very, very powerful feature without any impact using a feature called replication. So Hadoop master has very dynamic intelligence available as part of framework itself. Okay, so it can handle any kind of hardware failures in the clusters. I mean, it will try to say like the node failures or the system failures will not impact the applications that is running currently in the cluster. That is good part in Hadoop. Okay, so it will make still the application get successfully executed and get the results generated. Next is the cost. So database systems, they are fine cost-wise, but they also, cost-wise, if you see the customers, they will pay good amount for maintenance and support. Every year they have to pay good amount for support and maintenance. But if you come to warehouse systems, guys, these are very, very, very costly. Teradata and Netezza, right? They are proprietary tools, proprietary even the Arc and the cluster. They need very high-end hardware models, high-end hardware configurations like 64 GB RAM, 32 GB RAM minimum. High-end hardware processors, very high-end. They demand high-end hardware models and hardware processors. And these technologies are proprietary, and they do charge very good amount for the support and licensing nodes every year. They are very, very costly in terms of processing and storage and everything. Suppose, for example, to make it clear, so assume I have some 1 TB data, I load it into Teradata cluster. So if I want to process 1 TB data in Teradata cluster, it's going to cost around $16,000 for the customers. But if I want to process same 1 TB data in Hadoop, right, it's going to cost maximum $3,000. So if you see the cost difference, it's more than 5 times cheaper. So the reason why Hadoop is so cheap in terms of cost is because the Hadoop architecture itself is designed mainly to run on commodity hardware. So commodity hardware means cheap hardware. Don't have any limitation saying that Hadoop needs this hardware, that hardware configurations. Don't have any limitations there. Hadoop can run on any kind of hardware models and hardware configurations. This is a major breakthrough in Hadoop, these two features. And these two are the main features why basically most of the projects are migrating to Hadoop. So especially the mainframe projects and warehouse system projects. Because any customer, right, family friends, they will see only two things. How far the cluster is available, how much is the downtime. So they want the cluster should be maximum 100% available. And second is cost. They want the thing to be done as much as less cost. So both can be achieved in Hadoop. That's why many mainframe and warehouse projects are migrating. If you see the customers who are from mainframes, right, after migrating Hadoop, in my experience I see Okay, they are saving around 60 to 70% of the cost what they used to spend before administrative systems. Even the warehouse systems, they are saving around 40 to 50% of the cost what they used to spend on the warehouse systems before. Okay, so this cost plays important role. And next is type of data. So friends, here till now maybe in our academics or projects, so you would have worked mostly with the databases only, right? And we know what databases is going to store. They store tables, that is structured data, relational data. That means we'll have schemas, then we'll have the data. That means we'll have the structured data, the data with some meaning, right? But Hadoop, so even these systems also they can process only structured data mostly. They can process semi-structured data like XML files, JSON files. But coming to Hadoop, Hadoop has the capability to process structured data as well as semi-structured data like XMLs and JSON files. It can process unstructured data. Unstructured data means the data which don't have any schemas, no meanings, no metas. It's a simple raw data on flat files. And it could be again any format. It could be text format, binary format, compressor format, document format. So Hadoop has the capability to process any type of data. And you know, the unstructured data is the volume of data available in the world right now, it's more unstructured compared to structured. If we say I have total data available in the world is 100%, so the volume of unstructured data itself is around more than 80%. Only structured data is 20%. Why? Because see, this unstructured data plays very important role again in real time. And why such a huge volumes of unstructured data is generated means because the sources who generates unstructured data are more comparing to sources who generate structured data. For example, if you see unstructured data, if you take satellite data, some military surveillance data, some biological surveillance data, okay, call center data, social networking data, like Twitter data, Facebook